Everybody, we are going to learn differentiation today, and after the end of this lecture we will have the ability to solve the question based on differentiation that will be helpful in solving the numericals of physics, right? So this is not the whole differentiation which will be dealt in the mathematical section, and that is the part of mathematical section. So we are here only to discuss the differentiation which are helpful in determining in solving the numericals involved in physics, right? So moving ahead, and we are in the stage to learn differentiation. Okay, fine. So starting with some notations like delta. Okay, so delta means change, and change here is always final minus initial situation, right? Okay, so initial, final minus initial situation, right? So we are uh, basically basically learning a finite change here. This change is basically a finite one, finite, which can be calculated, which can be felt, which can be seen, which can be realized easily, right? It's a finite change. So whenever I say that, let's say delta v, where v stands for velocity, then you will say that it is final speed minus initial speed, right? If I'm saying this delta v is basically here change in speed, then it will be written as final speed minus initial speed. Okay, so the point is that here when I am using delta for the change, it means that change must be finite. It shouldn't be such small that we cannot calculate, or we cannot have the imagination. It is extremely low situation in which you can't imagine. Like if I'm saying that final velocity is 10.0000000 and too much times 0, it's not finishing, then 1, and initial velocity is only 10, right? So I'm saying, if I'm asking you what is the difference between the velocities or speed here, what is the change in the speed here, you will say, sir, it is 0.00000. Too much 0, you can't even have a confidence over the 0, and you can't have a finite value, right? That particular thing, that difference here in this example will be called as infinitesimally small difference. Infinitesimally small difference, right? For such type of changes where the difference is infinitesimally small, we do not use delta, but instead of delta we write d. Cool. Instead of delta we write d. Delta when we will use when there is finite changes, and we have a confidence over that thing. Let's say if v final is 15 and v initial is 10, I can say what is delta v. We will say that it is simply 5 unit, right? So there is nothing like you have to think about the situations which is very difficult to realize, which is very difficult to imagine, because it is extremely easy situation. But in the previous case, when we are dealing with this particular thing, vf minus vi, the difference is not going to be finite, the difference is not going to be exact some values. It is undefined, and it is very small value. And that's why for such type of changes we are not confirmly, we can't say confirmly that the difference will be this or that. Okay, we can only have the approximation, we can only have the some feel in our mind that okay, this difference is very small, which we can't imagine to the accurate things, right? So mind it, from the whole discussion I want to convey only one thing, that delta is for the change which is finite one, which can be realized, which can be confirmly said, okay, and on which we can have the confidence, right, that this is the difference, and there is no approximation, nothing great. Okay, but when we have a situation in which the difference can't be said conformly, we don't have the confidence over the value, we have to talk about the approximate values. In such type of cases, the delta becomes d, and this d will be used as a change for very small differences, that you can see infinitesimally small differences, right? Cool. So why we are discussing this delta and this d? Let's take a situation. Let's say that I am saying v, that means speed here, is varying with an equation, let's say 2t plus 5, where t is time. V is speed, t is time. Now try to understand, if I am saying that what is the difference in the speed, okay, when t is equals to 0 and when t is equals to 1 second. What is the difference in the speed? What is the change in the speed? Cool. Now you will say, sir, it's very easy. Let's put t equals to 1 here. It will become 7. Let's put 0. It becomes 5. Difference is 2. No problem at all. Now my question changes, that what is the change in the speed when t is equals to 0 and when t is equals to 0.00000 and so on. It is never going to be finished and it's continuing, and let's say 1. Okay, what is the difference? Now you can't say confirmly anything. You will say dv you have to calculate. This is being sure. Dv you have to calculate. Okay, now what is dv here? This dv is very small change in the speed. Very small change in the speed, okay, over this time duration, right? So let's say that I am saying that at t is equals to t, you have some v, let's say v, okay, and at t is equals to t plus dt, here d is very small, your v is v plus dv. Now let's try to understand that if I am asking what is the difference, what is the change in the speed over this small interval, dt, what is the change in the speed? You will say it is basically change in the speed is basically very small, and when you subtract final minus initial, it is coming to be dv, and this change in speed is coming in which interval? Dt time. Cool. Now if I am saying that let's write a term dv by dt, what will this particular term will describe you? It is basically describing rate of change of speed with respect to time. It will describe the rate of change of speed with respect to time. Or you can say that what will be the value of the change in the speed at t is equals to t, because dt is very small. What I'm saying, please try to understand. It can also be realized that dv by dt is giving the value of change in speed at t is equals to t. It will give you what? The value of change in speed at t is equals to t. Why I'm saying? Because dt time is very small. So basically, if you want to go mathematically, dv by dt is basically the rate of change of speed with respect to time. Let's an example, as we are all aware that dv by dt gives you acceleration. Okay, now if I am saying that what is the acceleration of this particular body following this equation at acceleration at t is equals to 1 second. Now you will say that how will I calculate t equals to 1 at t equals to 1 second the acceleration? When I say that acceleration is defined as dv by dt, that is change in velocity, rate of change of velocity with respect to time. Now at t equals to u 1 second, I'm asking you what is the acceleration. So the one thing which will come to your mind when it is change in the velocity and someone is asking at a particular time t, how do I get the change? From where do I subtract the velocity? Where is the duration? In this question, where is the duration? In this question, where is the duration of time? It is not given. So what you have to understand that whenever this question is going to be asked, whenever this question is going to be asked, you will realize first thing which will come to your mind, that is, this time can be taken a very very small value which can be said as still 1 second. Let's say if someone is going to be going to calculate at t equals to 1 second what is the velocity, and at t is equals to 1.0000000 and too much zero, too much zero, too much zero, and then 1 second, he is going to calculate another velocity, and thereafter he subtracted it and put the value of dt there, the duration, the change in the time, and you will calculate something. You may said, okay, fine, no problem at all. Basically what I am doing, I am calculating the change in velocity over that small amount of time, and which is starting from 1 second, what I'm saying, when this question is being asked, the first thing which will come to your mind, that t is, where is the difference in the time, so you will think, okay, fine, no problem, let's calculate t1 as 1 second, let's put t2 as 1.000000000 and so on. And then at this particular thing you will have v1, and at this particular thing you have v1 plus dv. Now you will subtract, it will come as dv, and you can say if this time is t and this time is t plus dt, so you can say it is dv upon difference in the time is dt, and this dv by dt is basically the acceleration, which will come out at t equals to 1, which definitely means that you have to calculate approximately with a very very small change in the time. I hope you understand what is the basic meaning of dv by dt. Basically, that is describe rate of change of speed or the velocity with respect to time here. And this rate of change means a very, very, very small change. A very, 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 very small, you can say, small change in the velocity with respect to time at a particular time t. What I'm saying now, I'm going to write down in one line that dv by dt can be read as rate of change of speed with respect to, this is with respect to time at. Now another way to write down, it can be said as that it is differentiation of velocity with respect to time, or you can say derivative of velocity with respect to time. Derivative can be said as derivative or you can say differentiation, or you can say change in speed in very small time duration from t is equals to t to t is equals to t plus dt. This is how you can say dv by dt all the way, right? Why it is needed? Just to have the difference at a particular time t, this small dt is very very small, so you can have the instantaneous things at a particular time. Okay, you can say it is also, you can also say it is instantaneous change in speed with respect to time. I have all the things which has been clear. Let's say it is basically why we are going to learn differentiation. Answer is simple. To get the instant change in any physical quantity, right? Instant change is being calculated in a very very small time interval. So whenever I'm saying what is the instant change, it's instant change in the speed of a vehicle going on a road at t is equals to 5 seconds. It means you have to calculate the change in the speed of the vehicle in the interval of 5 second plus 5 second to 5 plus dt second. Correct? I hope it is clear to you, right? And it is why it is necessary that to get the accurate change and to get the instant value of change which is needed in our day-to-day life. Many of the things are very very slow, many of the things are very very fast. In all the situations, if you have the tendency to go to understand the rate of the change, you can have the power of a speculation that after how many days that will be completed, after how many days that will be finished, after how many days the thing will happen. All the things can be calculated and you will have the power of speculation through this one. So mind it that why we are learning physics, to get the power of speculation, to get to estimate something, to derive something, and to predict something. This is called power of speculation. Okay, so now coming to the mathematical section, all the things which I have discussed till now is to give you the feeling of differentiation and nothing else. Okay, I hope it is clear to you all. Now coming to the mathematical part, I'll tell you that mathematical part, I'm not going to give you the derivation of each and every formula which will come in differentiation, since this will be completed in the limits and differentiability part, and this required the knowledge of different limits and differentiability basically. So this particular part will be dealt in the mathematical section, and you don't require here that from where this formula is coming in physics. You just have to memorize and have to understand the method of doing differentiations. So we are here to create a formula list, a very small formula list, which you have to remember in a proper way, so that you can have the ability to solve the question based on differentiation. Formula list. Let's say first formula, I'll tell you that let's say differentiation with respect to x of a function x raised to n will be n times x raised to n minus 1. Here n is a constant. Okay, great. Now next, and n is not equals to 0. Next, number 2, differentiation of something, let's say sin x with respect to x is going to be cos x. Next, differentiation of cos x with respect to x is minus sin x. Next, differentiation of e raised to x with respect to x is e raised to x. Next, differentiation of ln x with respect to x is 1 by x. Now, differentiation of any constant with respect to x or any variable, it is 0. Next, differentiation of a constant multiplied by a variable with respect to x. In this particular thing, constant will come out from the differentiation box, and differentiation will be done only of the variable part. So these are 7 formula which I have to memorize. That will be enough to solve the question of differentiation. in any way, right? So let's move ahead and try to understand the rules. First rule, addition or subtraction. Addition or subtraction. So addition or subtraction. What is the rule? If we have an equation y has u plus v, where u depends on x, function of x, v depends on x, function of x, and you have been asked to differentiate y with respect to x. Okay, so you can distribute the differentiation amongst the term. So you can say du by dx, you have to calculate, plus as it is dv by dx. Similarly, if y is equals to u minus v, and differentiation of y with respect to x is du by dx minus dv by dx. This is the rule. Okay, let's do a simple question. Y is equals to e raised to x plus x square, and we have been asked find the differentiation of y with respect to x. How will you do this? You will say, okay, you have to differentiate this one by the formula list. Answer is e raised to x. By the formula list, it is 2 x raised to 2 minus 1, which is e raised to x plus 2x. This is it. This is the answer, right? Similarly with the minus 1. Let's go to the rule number 2. Rule number 2. Product rule. Product rule. Product rule. Let's say y is equals to u into v. U and v are multiplying here. U depends on x, v depends on x. Now you have been asked to differentiate y with respect to x. What's the rule saying? Consider u as constant, differentiate v with respect to x. Consider v as constant, differentiate u as with respect to x. This is the rule, simple. Okay, let's do a question. Like, if I have been asked y is equals to sin x cos x, and you have been asked differentiate y with respect to x. Now consider this one as u, consider this one as v. Okay, u, v. Now put u as constant and differentiate v. Put u as constant, differentiate v.